Welcome to the distributive property of multiplication video. Currently in the scope and sequence, you are in the developing strategies for area unit. We have, prior to this unit, discussed fundamentals of area and understood that area is an attribute of a plane figure. So we're going to take those same concepts and we're going to look at arrays. And we're going to look at connecting area with arrays and counting the square units, and we're going to directly tie that to the distributive property to explore why the distributive property actually works. So let's start basic. If I were to ask students to build me an array with an area of 12 square units, one possibility that might arrive would be this array. And we would label this array as a 3 by 4, having an area of 12. It's very probable that you would also have students create an array with the dimensions of a 4 by 3. So those are two possibilities. Another possibility would be building an array of a 6 by 2. And again, changing the orientation to a 2 by 6. All at the same time, making sure that the properties of arrays stay the same. They should always make a square, a rectangle, and they should have no gaps. So we should be able to see that it's a complete array and it's not missing a piece that would not qualify as an array. So let's look at one more option for 12 that they would come up with. They might have a 1 by 12, which also would in turn be a 12 by 1. So we've just explored something that they should be pretty familiar with coming into this unit. They should know how to create an array, and they should also know how to interpret an array based on its dimensions. So let's take this concept and let's begin to relate it to a more difficult concept, which is the distributive property. Distributive property tends to be a difficult concept to understand, partly because we might start abstract with numbers. So what we're going to do today is show you how to connect this property to something that is more familiar with arrays. So let's start with a 4 by 3. Actually, I'm going to turn this for an orientation of a 3 by 4. So I would start with students after we've explored building an array with 12 square units. I would ask them to partition the array into 2 arrays. Okay, so that means this would not qualify as an appropriate response because these are not 2 arrays. I would need them to partition the existing array into 2 arrays, which would have to be a square or rectangle, again, no gaps in between. So let's look at one option that they might show you. They might partition a 3 by 4 this way. So if I look at the overall dimensions of this array, it is a 3 by 4, okay? However, when they partition it, I come up with 2 arrays. I have a 3 by 3, and I also have a 3 by 1. I can use this concept to help me compose the distributive property because I still have a collective area of 12 square units. So to use that concept and actually make it into a formula, I would have, this is a 3 by 3, which is what this is showing. And I'm connecting that, or adding it, that's why this would not be multiplication, I'm combining it, to a 3 by 1, which shows me 9 square units plus 3 square units gets 12 square units. So right here you have part of the distributive property. So let's look at another example. If they started back with their 3 by 4 array, they could choose to partition or break apart the array into these 2 arrays, which would get you a 3 by 2 and another 3 by 2. So when we look at this example, Again, thinking about we're going to combine them together, right? Because I could slide them right back together and they would add up to be 12. Or I've got a group of 6 and a group of 6, which still equals an area of 12. But again, connecting it directly to the distributive property, I have a 3 by 2, and I have another 3 by 2. So let's take this a step further. We know that this is going to be 6 plus 6 equals 12, but let's look and see where the parts of this actually came from. Like, where did those two 2's come from, and how does it relate to a larger picture? Well, this dimension actually stayed a 3. What we did is we changed this dimension. We decomposed the 4 into 2 plus 2. So that's why we arrive at the exact same answer. I want to show that piece because this actually connects to the beginning of the distributive property. Oftentimes we see the beginning of the distributive property to look something like this. 3 and then 2 plus 2. That's where we're getting this idea from, because 2 plus 2 is still 4, and 4 times 3 is still 12, but I'm breaking it apart just as I've done here. Let's look at another example and apply that same concept. So again, you've got your 3 by 4. Okay, and the directions in the very beginning were to partition this array into 2 arrays. So they could also choose to partition it horizontally. They don't always have to have a vertical line. They've just got to maintain the properties of an array. So this would be an array and this would be an array. So let's look and see how these dimensions have changed. I have 3, but I've broke apart 3 into a 2 and a 1. Okay? And then with 4, well, this dimension stayed the same. This is a 4, and this is a 4. So let's look at what I've done. I've got a 1 by 4, I've got a 2 by 4, but what I'm trying to show you is that one of these factors was decomposed. This factor was not decomposed because the 4 was a dimension in both rectangles. This factor, however, was decomposed into a 2 plus a 1. So again, if we look back at the properties of distributive property, we know that 4 was multiplied by 2 plus 1. I could have also written it this way, 2 plus 1 multiplied by 4. Those are the same thing. But I know that I broke it apart into 2 smaller arrays. So I have a 1 by 4 being added to a 2 by 4. All of these equal still an area of 12. Same idea here. This is still going to be a 3 by 4, which equals 12. This is why the distributive property works. And when you start concretely, it's very easy for them to be able to make connections with something that they already understand and then take it much further. So we start here to show you why the distributive property works. Let's talk about now the main point of distributive property and how it applies to multiplication facts. So we've done all of this conceptual work with actually breaking apart an array. You could move to pictures now with an array and actually break apart the picture by drawing a line where the 2 equal arrays are broken down. But now let's look abstractly and connect this to facts. So we'll start with a fact that is very commonly missed, which is 6 times 7. So if I use my knowledge of the distributive property, I could choose to break apart one of these factors, depending on what I'm more comfortable with, to help me figure out the answer. So if I'm struggling to remember what 6 times 7 is, I might want to break apart 7 into 5 plus 2, because 5s are pretty easy and 2s are pretty easy. So I've now changed this problem to end up being a 6 times 5 to a 6 times 2 and combining those 2 pieces. Okay, we showed that how that worked with area. So 6 times 5 is easy. 6 times 2 is easy. And now I see that when I decomposed the factor of 7 into 5 and 2, I was able to quickly arrive at 42. Let's look at one more fact and relate this to the main goal of the distributive property. Let's do 7 times 8. So I could break apart the 8, I could break apart the 7. There is no right or wrong way. It's more with the flexibility of the facts that a student is more comfortable with. So again, I'm going to kind of use the same strategy here. I know my 5s pretty well, and I know my 2s pretty well. And so if I use that same concept, this factor stayed the same. Okay, so looking at 8, and we broke apart the 7 into 5 plus 2. Again, the 5 plus 2 could come in front and the 8 at the back. You can see it both ways. But what I ended up doing is creating 2 smaller parts. I did the 8 times 5. And now I've done the 8 times 2. 8 is the factor that is shared with both parts of the 7 that we decomposed. And again, 8 times 5 is much easier for me to solve. 8 times 2 is much easier for me to solve. And now I can use the distributive property to help me build my concepts of facts and to also break apart numbers to have a little bit more flexibility.